So last year we discussed how can we use ANOVA to calculate when we are using independent between group design. Okay. So in today's class we are going to discuss repeated measure ANOVA, means how can we use ANOVA to calculate data when they are when we are taking repeated measurement, like when we are using within group design. Hope you remember we have discussed between group and within group design. So within group means when same participant, we are taking same participant in all condition. Okay, so we can use ANOVA in that situation also. So today we'll discuss that. So these are the topics that I'm going to cover today. First, obviously, I'm going to introduce you with the repeated measure ANOVA. Then I'll discuss the theory behind one-way ANOVA. Then discuss how can we calculate one-way ANOVA in SPSS, and finally I will discuss how can we use repeated measure. How can we calculate repeated measure with several IVs in SPSS? Okay.
Yes.
So the first one that I'm going to discuss is single factor repeated measure ANOVA. Like in the last class we discussed single factor or one-way ANOVA. Similarly, it is a one-way ANOVA, but it is repeated measure. So there is one IV. You can see I have written here one independent variable, and that variable has three or two or more. Sorry, the variable has more than two levels. Okay, it can be 3, it can be 5, it can be 100. Okay, and we'll use, but they are repeated. Means same participants are there in each level. So we are going to use this single factor repeated measure ANOVA to calculate such kind of design. Any question?
No.
So single factor means one IV, and repeated measure means we are taking same participant in all condition. Okay, fine. So let me start with a numerical example. So suppose I want to see effect of one treatment on something, maybe on achievement task or on some anything. Okay, so the treatment has five levels: T1, T2, T3, T4, T5. So like within group design we can divide this total variance into different subgroups. Okay, and as well as we can divide the DV into different subgroups. Now I just want to ask you, do you remember what is variance that we discussed in the last class? Okay. So like you can see here that we have divided the variance into between group variance and within group variance, and we further divided the within group variance into between treatment variance and residual. Now we have discussed that ANOVA means the true variance by error variance. Okay, so our objective is to find whether error variance is less than true variance or it is more than true variance. If true variance is more, then we can say that that effect has the IV has significant effect. Okay, so in between group design, the within subject variation was the error variance, but in within group design we want to see the within subject effect, so it can't be error variance. So you can see that the error variance has changed. Okay, so here you can see error variance is a residual. Residual means first we have to calculate the total variance. Okay, then from total variance and we will get between variance also. Then we will find within variance. If we a total variance minus between group variance, then we'll get the within variance. And from within variance we'll get between treatment, means between this treatments, this levels variance and the residual. So between treatment variance is our true variance, which we want to see that whether treatment has an effect or not. And residual means this is the thing which is extra and which is not we are not interested to know it. So we want to see whether between treatment is significantly greater than residual or not. So you can see in this this I have written total variance is divided into between and within. Within the within group variance there are treatment variance and residual variance. Okay. So the formula is, you can see between group between treatment mean square by residual mean square. Okay, so here we are interested to know whether this treatment are different from each other or not. Okay, so between treatment mean square is our true variance, and error variance means any difference caused by some other outside factors, outside factors or extraneous factors which create difference between different situation. So we are not interested to know this effect of residual variable. We are interested to know the effect of between treatment. Okay,
Hmm.
so uh, it is our, so between treatment mean square is our true variance which we want to see, and residual mean square is the error variance which we don't want to see. And our objective is to find whether there is significant difference between these two, or whether it is the whether between treatment mean square is significantly greater than residual mean square or not. Okay, is
Hmm.
it clear?
Yes.
What is the concept behind this
Yes.
one? Is it clear? Okay, any question? Okay, fine. So now, whenever we are okay, repeated measure ANOVA is also a parametric test, so we have to check the assumption. Now like in between group design, we say the assumption of homogeneity of variance means the two group they should be homogeneous. They should be, their variance should be homogeneous one. Okay, but in
Hmm.
within group design, we are taking same participants, so they are homogeneous, like same individuals I am taking in all conditions, so they are homogeneous, right? So
Hmm.
homogeneity, so it is basically we will think that okay, we don't need the assumption of homogeneity. But there is another thing which is called assumption of sphericity, which is very very important whenever we are using repeated measure design. Okay, so we
Hmm.
have to check whether our data violate the assumption, or whether our data fulfill the assumption of sphericity. Now the question is, what is assumption of sphericity? It is, suppose so assumption of sphericity means a difference between treatment levels. Okay, so the difference between each pair of treatment level, they should be like they should have equal variance. Okay, so these are the treatment levels. Okay, and the difference between the treatment they have levels, they should have equal difference. Sorry, difference between each pair should be equal. Okay, like you can see, sorry, difference between each treatment should be should have equal variance, means the difference between T1 and T2, T2 and T3, this level they should have equal variance. Okay, if they have equal variance, then only we can say that the assumption of sphericity is fulfilled. Okay, and if it is not, then we will say that the assumption of sphericity is not fulfilled. Is it clear?
Yes.
Is it clear? Okay. Now, how can we calculate it, the sphericity? Like we don't have to do it manually. SPSS will do that for us. But there is a test that we have to know. That is called. Okay, this is the concept of sphericity. You can see that variance between A and B, A and C, B and C. If there is three levels of three levels A, B, and C, then the difference between A and B, A and C, and B and C, they should be equal. Okay, that is the assumption. And if it is not, then we'll say the assumption is violated. Now there is a test which is called okay, let me come here first. You can see here in this example that three groups are here: group A, group B, and group C. Now this two A difference between A and B is 17, and A and C is 10, and B and C is like if we take the summation is 10.3 and 10.3. So these two are equal, but this one A and B is different from the other two groups. So we can say that this group has violated the assumption of sphericity. Okay, but here we can see they fulfill the assumption of sphericity. So this is a called local. You can see local sphericity or local circularity. Okay, this kind of thing called, because only these two group they are more variance, and these two group are different, but these two group are same. Is it clear?
Yes.
Okay. Now, how can we test the assumption of sphericity? Okay, we know that the group differ, but whether the difference is significant or not, that we have to know. From the score, we can say, okay, the variances are different. They don't have equal variance. Okay, but
Hmm.
it is not like it can happen like two group, maybe they differ from each other, but whether the difference is significant or not, that we have to know. So if the difference is not significant, then it's fine, we can tolerate that much differences, that much variance. Okay, but if it is significant, then we have to do some correction. So there is a test called mutualist test of sphericity. So this test basically it check whether the assumption is fulfilled or not. Means whether there is significant difference between the two variances or not. Okay. So if the test is significant, then we'll say that there is significant differences. There is significant difference between two groups. So we can the assumptions of sphericity is violated. And if the group test is not significant, then we'll say the assumption is fulfilled. There is no significant difference between two variants. Okay, so
Hmm.
SPSS will do that for us, so don't have to do it manually. Just we have to know there is a test called mutualist test, which we need to consider while doing before doing repeated measure ANOVA. Okay, so the concept of sphericity and mutualist test only applicable when we are using repeated measure, not in case of independent measure or one way ANOVA. Is it clear?
Yes.
Is it clear? Okay, fine. So, if now suppose I find that my test violate the assumption of sphericity, then what I will do? So there are two correction. You can see I have written here greenhouse, Geyser and Greenfield. Okay, these two correction. We can use these two correction to find the value of F test. Okay. Now, when we are going to use which one? When we'll use greenhouse and when we use Greenfield. Okay. So there are two things. First, you can see if the value of sphericity is greater than 0.75, then we'll use Greenfield correction. Okay, and if it is less than 0.75, then we'll use the greenhouse one. Okay, and this another thing, suppose okay, that one I will explain you later. Just now remember, if it is 0.75, then it is greater than 0.75, we'll use Weinfeld correction, and if it is less than 0.75, then we'll use Greenhouse-Geyser correction. We don't have to do anything manually. Just while doing the interpretation from ANOVA table, we have to consider them. Everything will be there, and you just have to select anyone. And most of the time, you'll find both of them are same, exactly same value they have. Okay. Now, another thing is that if some situation I'm not able to use this test, or I think that I will not use this correction, we can also do manova. Okay, because manova avoid any kind of assumption, so we can do manova. Again, I'm telling you, you don't have to do anything manually. It will be there in your output, and you just have to consider the score. Okay, clear? So what we have discussed, that when doing repeated measure ANOVA, we have to calculate sphericity. Sphericity means the variances between treatment, and it is expected that the variances are equal or homogeneous. If they are not, then we have to, if they are not, then we have to do some correction. And if there are difference, then we have to check whether the difference is significant or not. And if the difference is not significant, then we have to then the assumption is fulfilled. And if the difference is significant, then we have to do some kind of correction, like I have discussed greenhouse and Weinfeld. Okay, and otherwise we can do manova also. Right? Any question? Okay, fine.
No question.
Okay. Now, we'll discuss how can we calculate repeated measure ANOVA using SPSS. Once I discuss the calculation and output table, everything will be clear. Okay. So let me
Hmm.
open SPSS first. Okay. So file, import data. Okay. So this is the these are the treatment levels. Suppose now I don't need this one, but it will be there because after this one I will show you another thing. Okay, but for this calculation, just ignore this column now. Okay.
Hmm. Hmm.
So suppose these are the treatment level, different treatment levels. So I can write T1, T2. Okay. So now the you have to go to analyze general linear model and repeated measure. Okay. So
Oh.
once you click to repeated measure, you can find this dialog box. Here you have to write the factor. So this is T, sorry, T, and number of levels 5, and add it here. You can write the name of your variable here. It is treatment, so you can write, or add here. Okay. So here you have to send all your variables. Now we'll go to option, descriptive, estimate size effect, and homogeneity test. Homogeneity test means the mutually tested sphericity. Okay. Then go to EM means. Yeah, this one will do to check the correction. Sorry, check the post hoc test. So you have to send only your variable here, not this thing overall, only the variable, and click compare mean effect. Okay, and here you have to uh, click bond pattern.
Hmm.
Clear? Then continue. Then we'll go to um,
Plots.
plots. Just send your this one variable to horizontal axis and add. Then continue. Then we'll go to contrast. We'll use only repeated here, repeated measure, and continue. Okay. Anything else? No. Everything is done. So please don't think that this is too confusing, and don't be confused because I have written every step in my slides, so you can refer it. Okay. One thing I just want to show you, whenever you have any doubt like how to calculate or how what to do, you can always click to help, and if you have internet connection, you will get help here. Like, every details will be there, you can see. Okay, how to do this thing, everything is here. Okay, even the examples. So suppose you have doubt, sorry, suppose you are doing post hoc test. Okay, and you don't know, you find that this is it is not activated, so you don't know what to do, so you just click here and you'll get everything, every information here. Okay, like you can see every they have written everything about all the tests which are there in the dialog box, so you don't have to know worry. We'll see, and other related informations are there also. Okay, so you can do it for all the data, and all that it is there in all the dialog box. Okay, so it is clear. So what we'll do, we will first go to analyze general linear model and repeated measure. Then we'll get this dialog box. Here we have to write the within subject factor name, and if you want to write the your measure name, you can write here, or if you don't want to, then leave it and click to
Hmm.
define. Then you'll go to the main dialog box. Here you have to send all the variables in this type within subject variables box. Okay.
Hmm.
Next, then go to em mean. There you sorry, go to contrast, and there you have to write repeat it only, and then click to OK. Okay.
Hmm.
And then go to em mean. This one I have
Hmm.
included this slide somewhere. I think okay. A minute. It's not there. Okay, I will include it. So go to em mean. Send your variable here, not the this one, only the variable. Then click compare main effect and go for only one variable. Okay.
Huh.
Now we have all the informations, and now just click OK. So this is the output table. Is it clear? The steps are clear?
Yes, ma'am.
Okay, fine. Now, uh, output table. So, first object, obviously, we will have the descriptive statistics, that is the mean and standard deviation and n. Okay. Then, okay, this one I will discuss a bit later. Then we will check this one, mutually test of sphericity. And here we'll check whether it is significant or not. So we can see the p-value is less than 0.01. So it is significant. So we can say that assumptions is violated. Okay. And we can see the estimate value is 0.494, so it is less than 0.75, and when it is less than 75, we'll use greenhouse. So here we will consider greenhouse, but we can you can see that all of them are same f value, same significance, same partial eta square. Okay, but still you should know which one you should take. We should take. Okay, so as I have mentioned here, it is less than 75, so we'll use greenhouse kisser. Okay, we'll consider. I will say not use exactly. So we can take this one. Okay. Now it may happen that in your data, this greenhouse and this one when felt, they are different. Okay. In that situation, you have to take average, or you can use, if you think that okay, I'm not going to use this correction, you can take this. You can consider this table also, multivariate test. Okay. Now in multivariate test, you can see all of their different tests are here. Okay. The most popular one that we use is this one, with Wilks lambda. Wilks lambda. Okay. But they are all equal. So it's not like that they are different. They are all equal. You can see their level of significance, their effects as everything is equal. Okay. So, but the most popular one is this one that which we consider. So if you're first you have to check the sphericity test. If your sphericity test is significant, it means your assumptions of sphericity is violated. So then you have to think whether you are going to use this correction. And if you feel that okay, I'm not going to use this correction, then you can always consider this. Okay. So you will consider this one with lambda, although all of them are same.
Hmm.
Clear?
Yes.
Is it clear? Okay, fine. So you can see that they are all significant. Okay, the treatment they have significant difference both here we can see, and also this maneuver test it's also supported, and the effect is quite large, because if we multiply it with 100, it will be 79.6, which is greater than 50. So 50% is 79.6%, so effect is large. Here it is showing large effect, but here we can see it is showing small effect. So this is a time when you have to decide which one you are going to take. Okay.
Hmm. Hmm.
Then this is the contrast. Contrast, here you can see, like we say that we need to compare each level. Okay, so here level we compare level 1 and level 2 and found that they have significant. No, it is not significant at all. It's one. Okay, means they are not significant. Level 2 and level 3 not significant. Level 3 and level 4 they are significant. Level 4 and level 5 significant. Okay.
Hmm.
Again we can see the pairwise comparison here. The pairwise comparison means the um, post-hoc that we have calculated to see the pinpoint the difference. And you can see here the significant difference. 1 and 2 they don't have. 1 and 3 they don't have any significant difference. 1 and 4 significant difference. 1 and 5 significant difference. Okay, similarly you can see. So basically, this table this all table will give you information to explain your data. Okay, and again, I'm telling you, even if your data, even if in your main effect is not significant, you can interpret many things from all this data, effect size, contrast, and pairwise comparison. Okay, now this is the graph. Okay, so I discussed trend. I told you that today I will discuss trend effect, right?
Hmm.
So let me discuss it. Then we will discuss this graph. Okay. So in whenever we are calculating ANOVA, repeated measure, or even we can when we are using between group, we have to check the trend. Okay, and we can see there are four type of trend. This is linear trend when the relationship between IV and DV can be expressed by a straight line.
Hmm.
Okay, then this is a quadratic trend. Here, like with increase in IV, there is increase in DV up to certain level, and after that, DV decreases. Okay, so like we know the stress and performance with increase in stress, performance increase up to certain level, and after that, performance decreases. Okay, so this is a quadratic trend. Then the third one is cubic trend. Cubic trend means first there's increase, then decrease, then again increase like this. So this is called cubic trend. Okay. And finally, a quartic trend. In quartic trend, there is changes in three direction. First one, second direction, third direction, like this. Okay. So we have to see our data, and then we'll know the trend. So between treatment 1 and 2, you can see that there is no difference at all. They are same exactly, almost same. Even our contrast level support that. You can see here, level 1 and 2. Okay, 0 means square. Okay, then level 2 and 3, slight different we can see, but that is not significant. Here also we can see in the contrast 2 and 3. Okay, slight difference but not significant. In pairwise comparison also we can see 2 and 3 not significant, but there are some difference. Okay, now 3 and 4, huge difference we can see, and we can assume from the graph that the difference may be significant, but we can assume. To be sure, we need to consider the table, the pairwise comparison and contrast table. Okay, so yes, 3 and 4 significant difference we can see. Okay, and if we consider the pairwise comparison 2 and 3, uh, they are not showing in, 3 and sorry 3 and 4, yeah, significant difference. Okay, and then again there is some change. Okay, in relationship, like the effect is less, but it can be significant, it cannot be significant. So for that again we have to consider the table 4 and 5. 4 and 5 it is significant. Okay. So this is linear relationship, but this is sorry, this is not a linear one. This is linear relationship. Hope you remember yesterday we calculated one between group design, and we got a graph like this one, right? Quadratic trend. Hope you remember. Yes. So in this way we will check the trend, okay, and we can interpret many things from the graph. Okay, now it is visible, right?
Yes, ma'am.
Yes, I have changed the tab. That's why. Okay. So this is clear now. Trend analysis and how to interpret the output table. Okay. Now I just want to show you one thing. In this data, if we can know, it can be a mixed data. Like one variable is sorry, one factor is between group and one is within group. So if we consider this column, and we can create a mixed design like this. So maybe this is group. Okay. Okay, and I will add value. Okay, here we have two groups. Now just let me make it three groups. Then have let me go to variable view value. So 0 may be group A, 1 group B, and 2 group C. So this is a mixed data. We have mixed data means this one is repeated one, and this is the independent one. Okay. Now how we are going to calculate it? The same way we are going to calculate it, just a bit different, and interpretation will be a bit different. So same steps: general linear model, repeated measure. Uh, just mm, right. And go to define. Send your between on the within subject variable box and group the between subject factors. Okay. Then same thing you have to do. Option descriptive, perfect, homogeneity test, continue, EM mean, Pirani, continue, then go to plots, send your group to separate lines and treatment to horizontal axis and add and continue. Then go to post hoc. Now we have between group, so this one is activated. So just send your group to post hoc test, and we don't know it has homogeneity is fulfilled or not. So we'll click both Bonferroni and Game 7. And if it is homogeneity is accepted, means equal variance not assumed, then we'll consider the score of Game 7, and if it is not, it is assumed, then we'll consider the score of Bonferroni. from the output table. Okay, continue. And contrast. Contrast for group, for T it is, we'll consider repeated measure, and for group it is between groups, so we'll consider this one, polynomial contrast. Okay, and then we'll click continue. Okay, now, so this is the table we have here. General linear model between group and descriptive statistics we have. Okay, then within subject already I've explained you, we have between subject also. Okay, descriptive statistics, this is, then multivariate test, sorry, mutually test of sphericity we have within subject. Contrast, this one I have already explained you. This is a 11 test because we have one one between group variable, one independent variable, so this is the 11 test we have to do. Okay, test of between subject design, you can see interaction effect also. So the interaction effect is significant, but the group effect is not significant here. Okay, this is the contrast we can see here, linear and quadratic contrast effect, and it is linear one is significant and quadratic is not significant. Okay, so it's a pairwise comparison. Okay, and this is a pairwise comparison for the between group one parent in game server. You can see. Now let me see the graph. This is the graph we have for treatment. These are for the treatment, and this is for the three groups. Group A, this one. Group B, green one, and group C. So group C is a quadratic one. You can see a lot of changes are here. Okay, and then we have post hoc test. Any question? So we can calculate both between group and within group at the same time. Okay. Any question? No question. Okay, fine. So now I will discuss another complex design, that is repeated measure with several IVs. So we have discussed one-way repeated measure where we have only one IV, but again we can have more than one independent variable. It can be two, it can be three. Okay, and we have to then divide the total variance and DF accordingly. So suppose we have two independent variable, so we'll divide the DF in this way. Okay, total variance will be divided as between subject and within subject. Then within subject we have three variables, so we'll divide them into there will be a 6 division. One is for A and A into SS. A into SS, this is the error variable, error 1. Okay, then the A into SS is the residual variable for IBA, and so this is the error 1. Then B into B variable B and B into SS. B into SS is the error 2. And again we have interaction. We'll have AB interaction and AB interaction. This is the error 3. Okay, so we'll get 3 scores here for calculating the significant differences. Okay, suppose we have three IVs, then it will be a more complex one. You can see within group design we can divide it into in this way. For A, for variable A, then for two division for variable 2, B 2 divisions C, then their interaction AB AC BC, and finally ABC. So you can see so many divisions are here. So it can be anything. It can be two IBs, three IBs, four IBs, many IBs, and then it will be. We have to divide the variance in this way. Okay, is it clear? Is it clear? Okay. Now we'll check one example how to calculate repeated measure repeated measure ANOVA with several IB. Okay. So the basically the steps are same, and the output are also same. Just I will show you one. Let me clear it. Okay. Import data. So you can see I have two variables here, A and T. A may be something and T is another thing, and both variables are repeated measure. So I have three levels of A. You can see A, three levels of A. Okay, I have to write A1. Okay, I have to change, otherwise it's difficult. A1, sorry, 1, A2, and three levels of B, B1, B2, B3, and three levels of T, B1, B2, and B3. Okay, and three levels of T, 1, 2, 3. Here you can see. So this is a complex one, A1. Okay, three levels of A, three levels of B, three levels of C, and another. Oh no, 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 no! Just a minute. Okay. Mhm. Interview. Okay. Now we have to go to analyze, compare. Sorry, general linear model and repeated measure. Okay. But no, no, no. I have to change the name. Just give me a second. I'm getting confused now. It will be A, but A1, 81, 82, A1, A2, A3, A4. Okay. Now go to analyze, company, general linear model, repeated measure, then factor. One factor we have P, sorry, T, Another factor we have A, number of levels, we have 9. Okay, then go to define. Okay, just give me a second. Um, Clear it. Hmm, um, 1, 2. Okay. A1, A1. Okay. This will be A2, A2, right? Yes, now it makes sense. So we have to name use same variable A. I cannot use B and C here, then the spaces will get confused. Okay, now it's fine. Now go to analyze. Uh, General linear model, repeated measure. We have factor A, factor one factor is T. We have 3 levels. Another factor is A. We have 3 levels. Add them and then define. So send all the variables here. So it is very important how you just let me show you how you are naming your variable in this kind of complicated design. Even I get confused. You have to give them same name, but you have to denote them differently like this way. Okay, means you cannot write A, B, and C. Then SPSS will not take your data. Okay, you have to write them A, but you cannot write same name. So you have to separate your treatment some way. Is it clear? Okay. So go to analyze linear model and repeated measure. I have done this thing, define. Okay. Send it here. Then EM means send this thing, these two things to three things to display mean for. Then compare means effect. Go for boundary correction. Continue. Then post hoc. Okay, post hoc we don't. It is not activated. Go to plots. Send your treatment to horizontal and creating perfect lines. Or you can do reverse one also, no problem. Same thing. Then option, descriptive statistic, effect size, homogeneity, continue. Did I miss anything? Plot contrast. Will for both we'll do the repeated one as it is a repeated measure ANOVA. and continue. Now click OK button. So this is the result we have within factor descriptive statistics. Okay, these are the mean and this is the n we have. Okay, then okay, first we'll take the mutualist test of sphericity and we'll check the violation is assumption is violated or not. So you can see in case of T it is significant, so it is not it is significant means assumption is violated. But in case of A it is not significant, it means we can accept the means assumption is fulfilled. But in case of interaction the assumption is violated. Okay, now if we go to the within subject table. So here we have the data and we can see everything is significant. All of them are less than 0.01, so all of them are significant. Okay. And now if we check the contrast, you can see in same way we have to interpret, but there will be more levels. Level 1, level 2, and then interaction, level 1 versus level 2, and level 1 versus level 2, like this. Okay, interaction effect we can see here. And you have to check whether they're significant or not. So all of them are significant. Okay, and these are the effect size. You can see they have high. All of them have high effects except these two. Uh, this interaction effect. They don't have high effect size, large effect size. Otherwise, they have all of them have large effect size. So you can use each of this information to uh, interpret your analysis, interpret your data. Okay. Then this is a between subject factor. Okay, so between subject factor is not our like we're not concerned with it, so we'll not consider this one. So let me check the graph. Okay, this is a pairwise comparison. Okay, again we can see all of them are significant. And multivariate test, if you want to consider it, you can also consider this one. Okay, and now the pairwise comparison. Okay, uh, this is the graph. So we can interpret the graph also from the data. Okay, this graph is for A,
Hmm.
treatment A, IVA, these three colors, and
Hmm.
these are for B. So we can see the effect. Okay, here as the treatment change, how the variables are changing, you can see. Okay, so is it clear?
Yes.
And we can again use like you introduce one between group design here. So in that situation you have to create another variable. Okay, like, and you have to code it like this. And this is one maybe.
Hmm.
And you can change the decimal point here also from variable view. If
Hmm.
you remember, like this. Okay. So now we have mixed design. Two variables are repeated measure and IV, and one is between group. Okay. So then the design, then the output table will be much more complicated. But generally in real life research, we use complicated designs, so we can do that. Okay. There's one thing I want to show. So why we can't use three ABC three levels, that I will show you. Okay. Just let me clear it. Okay. Uh, so if my data is like this, like it was initially, so if I go to analyze and use general linear model, okay, and suppose P, 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 yeah, it will create confusion between within group and between group. Okay, so it is always better you name them like properly. Is it clear?
Yes.
Any question? So just remember, it can be a complicated one. You can include many variables, as many variables as you want, and then you have to handle them properly. You have to name them properly. That's it. That's it. Okay. And
Yes.
you are going to use your first. You have to check the assumption of normality and homogeneity. Homogeneity is there in the ANOVA, so you don't have to do separately. But normality you have to check separately. Okay, and then you will go for the ANOVA table, effect size, then the pairwise comparison, the graph. Okay,
Hmm.
fine. So
Yes.
next day we'll discuss non-parametric statistics, and then what we'll do, we'll take a data, and now after discussing non-parametric statistics, we'll know basic statistics by using SPSS. So we'll take a data, and then we'll do it properly. Means we'll check the assumption, we'll do the graph, and we'll check whether we can use parametric or non-parametric. Okay, and then we'll do the statistics. Okay, fine.
Yes. Yes.
Okay.